Good evening, my name is George and I'm here with my friend Tiago here. We're here to demonstrate how to calculate and draw a Mohr circle on a stress element. So we're given X and Y planes, X and Y faces. So on the X face we have a normal stress of negative 2,000 psi. On the Y face we are given 1,000 psi. For the shear stresses we're given on the X face you see here, the shear stress is 1,000 psi. On the Y face, the shear stress is negative 1,000 psi. A key point to note is that the shear stresses must be equal in magnitude, but opposite in direction. When it's opposite in direction, you're able to have equilibrium, and it'll have the shear stress. See, as you can see, the arrows are moving in the opposite direction. This one going that way, and this one going this way. So if you know your sigma x, sigma y, tau x or y, you're able to find the minimum and maximum shear stresses on any given coordinate. So my friend Tiago here will demonstrate how to plot these stresses on the stress axis.
All right, so let's just have our X and Y faces over here. For our first point, we know our X face is determined by all the stresses acting on that face, and sigma X is equal to negative 2,000, and shear tau X and Y is equal to 1,000. So let's plot that on the graph. That will be equal to negative 2,000 to the left and 1,000 up. So this determines our X face right there. For the Y face, we'll just do the same thing, which is sigma Y and tau YX. So 1,000 and negative 1,000 determines our Y face, which is equal right here. As you can see, you go 1,000 to the right and 1,000 negative, determines our Y face. Step number 2 is to determine the center of the circle. And in order to do that, we just draw a line from the X face to the Y face. And the way to calculate the center of the circle is just finding the mean average, which is given as sigma bar equal to sigma x plus sigma y divided by 2. That gives us our average, which is equal to the center of the circle. If we do the math, we have negative 2,000 plus 1,000 divided by 2 is equal to negative 500 psi, which happens to be right there, right across the x-axis, negative 500 psi from 0. Step number 2 is to calculate radius, which is this distance from here to the extreme. The radius is simple to calculate using Pythagorean theorem, which is equal to square root of 1,500, which is this distance here, from center of the circle to the extreme, plus the opposite direction on the Y face, going that way. So it's 1,500 square plus 1,000 square. That gives us our radius of 1802.8 psi. Now, after we have our radius, it's pretty much easy to determine our shear max, because, like, I'm going to kind of eyeball this here, try to draw this circle. As you can see, this is the radius. This is the radius right there. The circle goes this way. Circle here. There we go. And our tau max is determined, is equal to our radius, which is equal to 1802.8 psi. And it kind of makes sense because you know that this cannot go any further than the radius. So we have determined our shear max. Now, in order to determine here our minimum normal stress, is pretty simple, which is this distance here of the radius plus the distance of sigma bar. So it's given, actually, I'm sorry, it's not plus, it's minus. So the minimum normal stress is determined as the average, the sigma bar, minus the radius, which is this distance here, minus the radius, give us minus 500 minus 1802.8 equal to negative 2302.8 psi. So our sigma min is determined as negative 2302.8 psi. Now, in order to find our sigma max, which is on this side here, is simply same thing, but instead of subtracting, we just add the negative 500 plus the radius, so it's from here to there. That's our max normal stress, which is equal to sigma bar, sigma bar plus radius equal to negative 500 plus 1802.8, which is the radius, is equal to 1302.8 psi. The last part of this problem is to determine the location of these stresses in a normal plane. And my friend George here will come back to the board and demonstrate you how to find this location. Give it a minute. This is not Hollywood, guys. You know, this is all
This is real life.
real life.
So, for the angle here, we have 2 phi, and it would have an E set equal to the tangent, and the inverse of tangent, which is opposite over adjacent, and the values of those are 1,000 over 1,500. So the inverse of 1,000 over 1,500, we're given 33.69 degrees. So that's 2 phi equals to 33.9 degrees. You divide by 2, and you will receive 16.84 degrees. Now, if you were to take this and move in the counterclockwise direction, you would able to see this stress right here.
In which angle?
In this angle right here.
16.84, right?
Yeah, 16.84.
So if we rotate counterclockwise 16.84, we'll be able to see those stresses right there, right?
These stresses right here. Right.
The minimum stress, right?
Right.
Which is negative 2302.8 psi.
Right, and we have 1302.8 psi, sorry.
For sigma max.
Yes.
Now, what do you do if you want to find the shear max, the location?
The maximum shear max?
Yeah.
Well, first, we would have to find, the angle would be located right here, which is 2, see it clearer, 2 phi prime. Now, from here to here would be 90 degrees. So if you were to just simply subtract 2, if you have 90 minus 2 phi, you would be given 2 phi prime.
Then you can find the location of shear max.
Which would be right here.
Right.
So therefore, 2 phi plus 2 phi prime equals to 90 degrees.